channel, BBC or CNN, you just need to join IGMP multicast group. And when you want to leave, you just pretty much need to issue IGMP leave group command. And also in that case, when you are after you finish watching your TV or you feel like watching a movie, you can go purchase your video on demand by just choose and purchase. There are other functionalities, for example, like parental controls or small things like that. But pretty much this is the experience you're going to go through if you are a home user. And of course, if there are other interactive applications like karaoke or something like that, then you can definitely use that. So we talked about IPTV architecture in the overview, and I basically put them into 3 different sections. As I mentioned earlier, the first one is content source. And then the second part is management delivery network and home network. We'll go into each sections later in more details, but pretty much this is split according to the functionality, and it's probably different than the vendor for sure you will find on the internet. So I just want to let you know that. And most of the attack we found will be targeting the home network and also the management and delivery network. Okay, the content source, they are usually pretty separated from what normal customer will see, but it doesn't mean there's no security vulnerabilities, and we'll talk about that later too. So the first component is content source, and basically that pretty much means all devices, processes, and networks that import and store video content or broadcasting normal TV programmings. Those content come from different sources. It could be satellite, radio frequency, or the pre-recorded tapes, or either from cable modem or other type of sources. So the content source pretty much import all the content from different sources and then store into different servers with directories, with file servers to manage to get ready to deliver to the client. So basically that's what content source is for. And delivery and management network pretty much is all devices and the network used to deliver the video, and they deliver the video through the network to different customers. Okay, so that includes encoding and streaming servers. So basically change the content into multicastable data packets, or just performing encoding for that. Video on-demand servers, accepting user orders and then returning proper content to the user and performing authorization authentication. And also the network backbones. All the infrastructure, either you use VDSL, very high-speed DSL, or video DSL, or other different type of architecture and different network devices and so on. Okay, so their major functionalities is what we were talking about: customer authentication, authorization, and customer service. And also, they provide video content, either the normal or on-demand, through multicast and unicast, as we talked about earlier. The home network, usually we call the device or the equipment at user's home, we call them like customer premise equipment, or CPE. And that's basically anything that connects to a consumer's home network or inside this home network. We're talking about the computer you own, we're talking about a set-top box you own, and the home gateway if you use one, the game console in the future, your phone, and anything else in the future. So that's pretty much the cover or the scope of the home network. Okay, so the next thing we want to talk about is basically the attacker scope. So think about that. After you look at the architecture, you look at the content. If you want to attack a telecom, what would be your goal? So we pretty much think the goal will be 2 of them. The first one is try to take control of a large amount of home networks as much as possible. And what you can do, you can perform service disruption. You can spreading worms, trojans, virus, and you can broadcast your own material for either political motivation or whatever purpose you have. So that could be one potential goal that the attacker could have. And the second thing is more simple. Basically, you just want the content. You just want free TV, you just want free movie, and or someone wants to rip up the content as simple as being a peer-to-peer TV source, sort of things like that. So That's kind of the two potential goals. Of course, some people, they may also want to take over the telecom infrastructure, trying to get to every user's account and things like that. Potentially, that's another like internal internal threats and that type of thing. So. And the next section we'll talk about is some of the known security problem we have seen on different components, including home network, delivery, and the management network, and also the content source. So the first thing is for the home network. When people want to try to test the home network, the major thing you want to understand is how does the authentication and authorization are done. Okay, it could be as easy as spoofing a MAC address. That's actually some of the cases we have seen that people only use MAC address to perform authentication or authorization. And it could be as complicated as using like AL2.1x to do EAP control, and if you are not on the customer list, you are not going to get on the network, you won't be able to watch the TV at all. So it could get very simple, it could get very complicated. The point here will be that for different service provider, they will actually do different things. So what you have seen here may not work for every telecoms. And there are a lot of security vulnerabilities on home network devices, including how the device is managed, how the device, if there is any other vulnerabilities on the devices. So as we mentioned earlier, we want to know more about the authentication and authorization. So here is a typical setup box communication with the servers. Of course, the first thing, they download the boot image from the TFTP server. TFTP doesn't have any authentication. It's not, no authentication is required. That pretty much means if a setup box can download the file, you can download the file. Okay, so you pretty much get the same thing that a setup box could get. And then setup box could register itself to a middleware server. In IPTV infrastructure, you will see a lot of people using middleware server, and those middleware are taking user requests and authorize them to see if they are authorized to watch the video on demand or if they can do something else. And then setup box will receive a channel listing, application directories if there's something other than just videos. Okay, so that's what setup box will see. And then setup box will issue an IGMP membership report. And some of the vendors, they might use IGMP version 3, some of them might use version 2, and to indicate the current channel or if they want to join a new channel. Leave group. If you want to join a new channel, first you have to leave the current channel using the IGMP leave group message and to leave the channel. And also, sometimes for some of the setup box, they will actually send out a power off packet. Okay, so the setup box is actually not completely power off. It's kind of into a standby mode or kind of like sleeping mode, and it could be wake up pretty easily, so to boot up faster. Device management problem. A lot of the devices, they are still being managed by SNMP and Telnet. Okay, so whenever you found, sometimes it's just on a different port. You have seen all different advisories against different devices where there are management interface running on port, say 27,000 or something like that. You know, so for different setup boxes, there are different ways to manage them too. For example, using Telnet, some of the setup box, they actually have Telnet either running on the standard port 23 or on a non-standard port. And the point is, most of the time when you Telnet into a setup box, you are root directly because most people doesn't bother to secure the Telnet management interface too much. So one of the example we were able to find is once you Telnet to the setup box and then you know the port by scanning the setup box, of course, you automatically get like kind of like a prompt, and you can actually perform like leave M group as leaving this current multicast group, and then you can join M group. For example, if you want to have your neighbor watching the Playboy channel while they are, while they are not aware of that, so you can do that and perform this just to have the other setup box join a different group, which means changing a channel. And information transmitted in the clear. So we mentioned earlier that setup box has a lot of information. For example, PIN number for parental control or VOD purchase, We have found cases where the PIN number is actually not protected, not encrypted. All the traffic is running on clear text, and you can even change that on the fly. So people could just post it on the online forum and telling teenagers how do you bypass the parental control of certain vendors' IPTV product. Things like that could happen. And another thing is account number. So the good thing is we never found anyone basically passing like sensitive information like social security number or people's name, anything like that. It's pretty much represented by account number or using the MAC address authenticated with a backend database. So that kind of reduced the concern regarding to privacy. And local access to device. Once you get a set-top box, pretty much you own it, right? You can do anything with it, and as long as you don't care about the acceptable usage policy, you can do whatever you want. So one thing people could do is basically just simply plug in a USB keyboard or mouse. That's what you do to any device that has a USB hole there. And some of the set-top boxes, you can actually get command shell access on Windows-based set-top boxes. This is not Telnet. So Telnet, you have to do it through the network, right? And this is totally like a local access to the device. And how you usually do that is kind of like kiosk security, where you plug in the keyboard and the mouse, and then you basically, the first thing you want to get is like a program like Internet Explorer or any type of thing that would browse to the internet and have the access to the local file system. And then you can basically press like F1 for help and or some different key sequences where you can call another place, where you can call like multimedia player or something with a file menu. And then at that point you can put in like file column / to get access to local system. So we have done that, and we have seen one of the set-top boxes. Actually, there are tools on the set-top boxes where you can modify the content of the EEPROM. And as we mentioned earlier, if your set-top box, if your IPTV authentication is based on MAC address of set-top box, at that case you will be able to change the MAC address on that set-top box, and you can become whoever you are. Think about that. Most of the providers, they have the set-top box manufactured by one single vendor, which means the MAC address are pretty much fixed, right? So all you need to do is just kind of go through the sequence and try to guess other people, and you can get some subscription for free. And it could be you might have access to other information, for example, like DRM related private key or public key or anything like that. Okay, so that's also possible that if you are able to locally compromise the DRM, compromise the set-top box, because if the vendor is going to implement DRM, some of the information will be stored on the set-top box, and once you recover that information, there's an opportunity you can break the DRM. And we at TCP/IP stack. So we found that basically, most of the set-top boxes, they have limited memories and resources to use. So when you are watching TV, actually the set-top box, certain type of set-top box, they will open a service listening on some high port running UDP just to listen to the multicast traffic. And at that point, you can pretty much, you can use ISIC to do the test. Pretty much use the UDP-SIC, which will generate random UDP packets to test the stack integrity. And for some set-top boxes, this is going to be denial of service. The set-top box could be killed and then automatically reboot, and it may not even come back in some cases. It could be a useful case if you want to perform a denial of service on a large home network of certain telecom. For example, you take control of most of the computers on the home network for the customers, and then you install a malicious program and launch the denial of service attack at certain time automatically and to reach the effect. So this is one of the problems that could happen, for people to utilize that. There are other vulnerabilities, for example, web management interface, data validation problem. We have seen problems like file system traversal problem on